everybody, now let's learn probability about addition rule of probability, mutually exclusive events and non-mutually exclusive events. If you are not familiar with this topic, and this video is for you.
Now, let's talk about first addition rule of probability. Definition of addition rule of probability. The addition rule of probability is rule used to calculate the chance that at least one of two events will occur. It combines the probabilities of two events while avoiding double counting of outcomes that are common to events. For example, if two events overlap, we cannot simply add their probabilities because some outcomes may be counted twice. That is why we subtract the common outcomes.
So, for further understanding, the addition rule of probability is the main formula used to find the probability that event A or event B happens. It applies to both mutually exclusive and non-mutually exclusive events, but in different ways. You can see it later. So, the general formula of the addition rule of probability is the probability of A union B equals probability of A plus probability of B minus the probability of A intersection B.
Have you ever wondered if two events can happen at the same time? For example, when tossing a coin, can we get both heads and tails at the same time? The answer is no. This leads us to our topic, mutually exclusive events. So what is mutually exclusive events? Mutually exclusive events are events that cannot happen at the same time. If A and B are mutually exclusive, then A intersection B is equal to non-empty. This means the events have no common outcomes. So the formula for exclusive events, the probability of A union B is equal to the probability of A plus the probability of B, because the probability of A intersection B is equal to 0. So let's proceed to the example. A single dice is tossed once. Find the probability of A 2 or 5 turning up. The sample space is S is equal to 1, 2, 3, 4, 5, and 6. We assign equal probability to the sample points. We assume the die is fair, then the probability of 1 is equal to the probability of 2 to the probability of 6 is equal to 1 over 6. So when you roll a die, you can only get one number at a time. So you cannot get both 2 and 5 together. That's why they are mutually exclusive. The dice has 6 possible outcomes. So it's 1, 2, 3, 4, 5, and 6. Each number has the same probability. So this is probability of 1 is equal to probability of 2 is equal to probability of 6 is equal to 1 over 6. So the event that either 2 or 5 turn ups is indicated by 2 union 5. Therefore, the formula of mutually exclusive is probability of A union B is equal to the probability of A plus the probability of B. So the probability of 2 union 5 is equal to the probability of 2 plus the probability of 5 is equal to 1 over 6, because the probability of to get 2 is 1 and the probability of 5 is to get is 1 over 6. So add 2 over 6 or 1/3, simplify, it's become 1/3.
Now let's go to another example about mutually exclusive events. So when rolling a die, a fair die is rolled once. So we need to find the probability of the two events where event A is getting an even number and event B is getting an odd number. So in the event A, so we need to find the probability of getting an even number. So we know that, first is what is even number. So we know even numbers are numbers that are divisible by 2. And event B is getting an odd number. So what is an odd number? So an odd number is a number that is not divisible by 2. So these are mutually exclusive because a number cannot be both even and odd at the same time. So here are the solutions. So step 1, list the sample space. So what is the sample space? We know that sample space are the list of possible outcomes. So in rolling a die, we have 6 sample space. The 1, 2, 3, 4, 5, and 6. So next step is the list the events. So in the event A, we need to find the probability of getting an even number. So among the 6 sample space, the outcomes of getting an even number are 2, 4, and 6. Next is the event B. We need to find the probability of getting the odd number. So the outcomes are the 1, 3, and 5. Next is the step 3. We need to find their probabilities. So in the event A, which is the even number, we have 3 outcomes. And we know that there are 6 sample space. So it is equal to 3 over 6, or in the lowest term, it is 1/2. So in the event B also, it has 3 outcomes, which is the odd numbers of 1, 3, and 5. So it is just over the sample space, which is 6. That's why it is 3, 6, or 1/2. Next is the step 4, the mutually exclusive formula. So we need to apply the formula, which is the formula of the probability of A union B is just equals to probability of A plus the probability of B. So in the probability of A, we know that it is 1/2, and the probability of B, it is also 1/2. So we just need to add the two events. So 1/2 plus 1/2 is just equals to 1.
Hello each and everyone. Now, we are going to continue our discussion about non-mutually exclusive events in probability. For definition, two sets are non-mutually exclusive if they share common elements. Non-mutually exclusive events are events that can happen at the same time. This means the two events have something in common or shared outcomes. Consider the set of all numbers from 1 to 10 and the set of all even numbers from 1 to 16. Look in the example shown. We have set A and set B, and both set contains the numbers 2, 4, 6, 8, and 10. Notice that some numbers appear in both sets. These shared numbers are called common outcomes. Because of these common outcomes, the two sets overlap. The Venn diagram helps us visualize the overlapping events. The shaded middle part represents the outcome shared by both event A and event B. To solve the probability of non-mutually exclusive events, we use this formula. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. If A and B are two non-mutually exclusive events, then the probability of A or B occurring is both of their probabilities added together and subtracting the probability of both of them occurring. First, we add the probability of event A and event B. Then, we subtract the probability of both events happening together. We subtract the overlap because it was counted twice when we added the two probabilities. For further explanation, one of my group will show you some examples for you to understand what non-mutually exclusive events is.
Now, let's have the number 1 example about non-mutually exclusive event. In a school of 120 students, 70 students join the math club, 55 students join the science club, and 30 students join both clubs. Now, what is the probability that a randomly selected student join the math club or the science club? So we have the solution. Let's use the formula for non-mutually exclusive events, which is the probability of A union B is equal to probability of A plus probability of B minus the probability of A intersection B. And now we have to let A is equal to students in math club and let B is equal to students in science club. We are going to substitute the values, which is the 70 over 120 plus 55 over 120 minus the 30 over 120. Then we have the 95 over 120, and if we divide that, we got the 19 over 24 or 79.70. And that is the final answer. That's all. Thank you.
Hope you learned something!